The time scaling operation, as we have discussed, it can be performed on both continuous time signals and discrete time signals. Time scaling, let us consider x of t is the original signal. First we are discussing about continuous time signals, so I have taken x of t. Then x of at is the scaling version of x of t, means it is the scaled signal of x of t. Let us take an example. I have considered a signal x of t and performing scaling operation. Here a is a constant. First I am considering x of 2t, later we will go to x of t by 2. There is some conclusion that we need to get after, after getting these two signals. Here also the amplitude does not change, but the time intervals change. The signal x of t, original signal, is defined from 0 to 2. So x of 2t is defined from 0. To 1, and this is defined from, here is a small tip, this time intervals must be divided with a scaling factor. Here the scaling factor is 2, so I am dividing the time intervals by 2. If 0 divided by 2 is 0 and 2 divided by 2 gives 1. This is the tip. The time intervals must be divided by the scaling factor to obtain new limits, new time intervals or new limits. Coming to x of t by 2, it is 1 by 2. So 1 by 2 divided by 2 becomes 0 and 1 by 2 divided by 2 becomes 4. The amplitude remains same. Now if we observe the signals x of 2t and x of t by 2, x of 2t is the compressed version of x of t, because here the time intervals of 0 to 2 and here it is confined to 0 to 1, and taking x of t by 2 signal, it confines between 0 to 4. So this is the expand version of x of t and this is the compressed version of x of t. So we can say that if A is greater than 1, then the obtained signal is compressed signal, and if A lies between 0 to 1, it is the expanded version of signal. Expanded signal of the original signal. Now let us consider the third operation, time reversal. The time reversal has another names also, like folding, reflection. For continuous time signals, let us consider x of t let us consider the signal x of t. The time shifted version of x of t, the time reversal of x of t is x of minus t, that is from 0 to minus 1. means the origin remains as constant, origin remains as it is, but the signal is folded, or we can understand it betterly as a mirror effect. The signal is folded, the origin remains constant, and the right sided shift time signal comes to the left side. For discrete time signals, let us consider a discrete time signal, and the time shifted version of the discrete time signal is as we have observed, similarly in continuous time signals, the origin remains constant. In discrete time signals also, the origin remains constant, and the right part of the signal is shifted towards the left, as we can see here. We can have a doubt that if in problems, if these three operations are need to be performed, then which one should be operated first on a signal? This can be, as we have in mathematics, Bodmer's rule. In signals also we have some precedence rule. The order is time shifting, time scaling, and time reversal. This is the order that need to be performed while solving a problem. Let us take an example which includes these three operations. X of, sketch the signal x of minus 2t plus 3. So to sketch the signal, as we have seen in the precedence rule, first go with time shifting. Okay, first let us take the original signal x of t. If this is the original signal x of t that I have considered, so on this signal, from this signal we need to obtain this signal. So to this signal, first I'm doing time shifting operation, that is x of t plus 3. As we have seen here, t is negative, so that plus came because we know that x of t minus t naught, if t naught is negative only, here plus comes. So it is left shifted version of t, x of t. So the signal moves 3 units towards left. So the original signal is at 0, so it moves 3 units, so it goes to minus 3 to minus 2. Okay, we have done the x of t plus 3, the shifting operation. Now we are going to perform time scaling. Coming to time scaling, this signal, to this signal we perform the time scaling operation. The signal becomes x of 2t plus 3. As I have told earlier, the scaling factor is 2. So divide the time limits by the scaling factor to obtain the new time limits. The actual time limits are minus 3 and minus 2. So I am going to divide with 2. So the obtained limits are minus 3 by 2 and minus 1. Okay, now to this time scaling version of signal, we'll perform time reversal operation to obtain the signal that they want, that is x of minus 2t plus 3. See, time reversal is nothing but folding. So this signal, the signal which is in the left part of the x-axis comes towards the right part, that is 1 to, 3 by 2 to 1. So 1 to 3.